Hello everyone and welcome to a new episode of Binary Wizards educational series. Today I'm gonna be talking about GhidraSQL. It will be the second video in the series of Vibe Reverse Engineering. Last time I spoke about IDA and I explained the concept behind the SQL family and why I call it Vibe Reverse Engineering. So today we're gonna talk about Ghidra and how to set up GhidraSQL and the dependencies, and also just the basic workflows, how you can use it. Now, the biggest advantage of Ghidra is it is accessible to everyone and it's free and open source, so you can use it. Some people are fans of one tool versus the other. Here, I'm just focusing more on the tooling I created and how that will give you a seamless experience disregarding the back end, whether it's IDA behind the scenes or Binary Ninja or Ghidra. So from the vibe reversing experience is going to be the same, and I would say around 60% of the brains is your AI agents and your harness and the model that you use. And the remaining percentage depends on the tool. So maybe IDA will have better output in the decompiler and maybe better reversing and cross-referencing abilities and whatnot. But that's one aspect. Once we combine the LLMs, then this difference will not be huge in the long run. And eventually that the difference between Ghidra and IDA and any other tool would almost disappear, honestly. So let's get started. All right, so let's take a look at the repo. So a couple of things here I'm gonna just mention just for multiple purposes. So first thing is I'm gonna be linking the repo in the video description. Here's the repo here on my personal GitHub account. As of the time of recording, this is version 0.04, which have a lot of bug fixes and additional features and comparable to IDA for example. So GhidraSQL is a SQL interface for the Ghidra tool essentially. So instead of you having to learn how to use all the Ghidra APIs and whatnot to do agentic reverse engineering, you can use GhidraSQL. So it will present a set of virtual tables and in conjunction with skills, which we're going to talk about. And the way it works is very simple. Your agent will have a view of Ghidra or wherever you're looking at Ghidra or even headless Ghidra as if it was a set of SQL tables. So if it wants to know about functions, it just look up the functions table. If it wants to know about something else like cross-references, decompilation, everything is in SQL surface and it's a live surface, which means that not just like I can select from, I can update, I can delete, and so on. And that will give your agent a very powerful surface to really approach the Ghidra as a database system. So GhidraSQL itself relies on a secondary tool I created, which is called libghidra. And libghidra deserves its own video in the future. So what is libghidra real quick? It's also a Java extension that lives inside Ghidra and creates an RPC channel so that you can externally outside Ghidra you can do API calls. And libghidra itself has its own wrappers, so you will not see one-to-one mapping between your familiar Java Ghidra APIs and my RPC library libghidra. Instead, it's gonna be its own APIs. And on top of that, I also give you bindings for different languages. So if you want to use Python, if you want to use Rust or C++ to drive Ghidra remotely, which means you can either have Ghidra headless and then just automatically use it as if it's a library on its own, or you could open it, you could have Ghidra open and your IDE open on the other side and do some programming. So for example here, we are doing, we're launching it. So we didn't have Ghidra UI, we're simply launching it. We're specifying where's my Ghidra version and what's the project directory and name. And if we want to save our work, and then simply we are starting from a fresh import. We're importing and analyzing a binary completely programmatically without having to touch the Ghidra user interface. And then we can do other actions after we open. Then now we have Ghidra database. We can query for functions, cross references, and write a custom whatever detection or improve the analysis and whatnot. And this will also give you not just Python, as I said, so you could do the same, for example, here in C++, you can do the same stuff remotely. Now, the advantage of this is quick iterative programming. So you don't have to close a Ghidra each time you rebuild the Java extension if you used to work in Java. Or if you're using those Python bindings, you don't have to reopen and so on. But this is the nice thing about this. This is external, so you can experiment as much as you want externally. That's the beauty of it. And so this library is a prerequisite to GhidraSQL. So GhidraSQL takes libghidra, which is a set of API calls, and then projects them into a SQL surface. So really here, if I want to make something very simple, poor man's drawings, we can think of here, first box here, second box here, and third box here. There are multiple layers of indirection. And we can think here that this is the Ghidra distribution binary. We can think of this as the lowest layer. And this is where we have the Ghidra Java extension that I built, the libghidra host. Then the second layer, we can think of it here, is the libghidra. That's what I was just talking about. And finally, we can think here is the GhidraSQL surface. With all those three layers, now, this is what we're going to be talking about today. Those three layers, eventually, the whole architecture here is just to finally allow to do something extremely simple. So we can put a boundary here. We can say this is all hidden. And then what we really end up with, we can say here is the vibe reversing. So here, now we can do vibe RE. Now we will be able to do vibe reverse engineering using two sets of surfaces. We can use the SQL surface. That's the first one, and that's what I'm going to be talking about today. Or we can do vibe coding as well, and the second surface would be directly talking to libghidra. Can I talk to Ghidra distribution and binary as well through another surface? Yes, of course. There are people who do other things, and so for example, I don't dabble in these stuff, but there are other surfaces. So for example, people use another connector, like some Ghidra MCP, whatever, right? But I do provide an MCP just in the passing, and I prefer either a libghidra approach through RPC or a GhidraSQL surface, which is much more powerful. So this is the architecture essentially. So if I go back to GhidraSQL, this is how it is designed, and it's gonna be a seamless experience. So you don't have to know any SQL. You don't have to know any of the details. We will see when I talk about installation. Once we have it installed, then all you have to do is go to your coding agent and just talk naturally in English. Hey, open this binary, reverse engineer this and that, and so on. You don't have to have technical skills, SQL knowledge. You don't even have to know what's Ghidra, to be honest. Once you have it installed, you just speak in English and you query the binary, like how does it implement this? I don't know, how does it implement key management? What crypto algorithms does it use? Could you give me back the source code? Can you port this driver from Windows to Linux, for example? Could you reverse engineer the protocol for me and document it? Could you port this old game from one platform to another? I only have the binary. You can do all this naturally. And that's the vibe reversing aspect out of it. All right. So back to the repo, and the first step is installation. Now, this is built from source, all right? So I like to approach Ghidra since Ghidra itself is open source. And my toolset here requires you to build them on your machine. And because of that, there will be lots of variables on your machine. It could be uh, lacking dependencies and whatnot. So the best way really is to just follow the install prompt if you wish. Or of course, you can read the documentation here, clone this, clone that, run this command, and so on. But then maybe you have a missing dependency, maybe something different on our machine. So that's why I put it immediately at the top. It's really, since anyway we're doing vibe reversing, and so this is AI first project. Everything's gonna be driven by your coding agent. So why not just take a step back and let the agent do the installation? So if we look at the install prompt, this is something we can give to our AI agent. You say, hey, this is the repo, read the install prompt and install the program. If we look at it really, it's for AI agents or humans alike. So we're describing the dependencies. So when the AI reads this, it knows exactly, okay, so I have to check if the system has GDK, if it has CMake. And so these are hints for the AI to know what to do, how to probe the system. Most models are smart enough, they can quickly go over step 0 and check the system dependencies. They could do maybe a couple of tool calls and they're done. And then it instructs your agent to simply go grab a build of Ghidra from the NSA. If we tweak the prompt slightly, we can ask it go and build Ghidra from sources. You don't necessarily want that. But basically, it just nudges the model, hey, go grab a build. So we're not necessarily saying which one in particular. And it's just, what we call in-context learning. We're just hinting the model. Then, all right, clone the dependencies. So we're advising the model to clone my projects, the libghidra dependency and GhidraSQL itself. And finally, it's nudging it to build my projects from sources. Now, for my projects to work, there are a bunch of stuff I haven't spoken about, especially for libghidra. Libghidra is more powerful than what it looks. I will have a dedicated video. So libghidra requires some patches for the Ghidra sources, and we will build some stuff from source inside Ghidra, especially the decompiler part. Because libghidra itself can work completely outside the Java environment, offline mode, as I call it, to leverage the decompiler. So you can really have a fully distributable libghidra static library containing the whole of the Ghidra decompiler. Maybe it's around 8 megabytes or so, but if you take that core, now you have yourself a fully standalone static Ghidra decompilation core in libghidra. Then you can write your custom CPP code or Rust code, and you have yourself an independent Ghidra brain with decompilation abilities. And then it nudges the model here to build GhidraSQL. And this might seem simple. Yeah, let's just build it. Of course, now those should work flawlessly, the CMake build and whatnot. But also, there's so many systems, so many configurations. So in the environments I test, like in one simple Linux flavor, for example, they work flawlessly. But as we'll see, I'll show you how you can get this to work inside ChatGPT virtual machines. And so you can have this completely inside the sandbox. And let's say a computer that you do not own yourself, you can do reversing from your pocket, from just your phone, with no computer at home, no nothing. And that's why building from sources and install agent is. And then at the end, it will tell the model, the install prompt will tell the model, just do a quick smoke test. Hey, pick a binary of your choice and see if everything is properly installed. So then it invokes GhidraSQL. The binary, it points to wherever the GhidraSQL installation is, passes the binary in question, and just starts the server. And that's the install prompt, and nothing else. Then it tells the model to shut down the GhidraSQL provider, and off you go. That's it. So that's the install prompt. You can follow it as a human or not. All right, so let me get back to the practicality of it and show you the setups phase. So one thing that drew my attention, I was taking a look at the GitHub issues, and what I saw, I closed most of them. There's nothing really to do. But it seems in the past week or so, people made a meme out of the section here about the installer. Install with an AI agent, and basically I did explicitly say that the best way to work with GhidraSQL is to let your agent install it, since this is an AI forced tool anyway. So it's best to let the AI install it as well. And then we will just do vibe reverse engineering using AI, of course. This is the whole point. But yeah, a barrage of really extremely unproductive issues. So yeah, let's just take a look. One of them is like pointed me to the Reddit post here, talking about basically they kind of made a meme out of me, which is good. So here, just let AI do it. And basically, this is what triggered them, as if they never really used um, coding agents or follow up with the trends. I mean, come on. Anyway, I just like scroll a bit, and all I can see is bashing, calling me names, calling me lazy, and then like I'm a horrible person to work with. And there are like a few sensible voices that's like, yeah, this is normal, this is how things work, Cloudflare does it. In fact, if you don't do it, you're wasting your time. Um, okay, if you don't want to do it, I mean, come on, you just read the instructions and do it yourself, right? Like nobody's forcing you to use any agents whatsoever. But I was trying to find anything substantial here, and all I could find is just simply um, bashing and ignorant posts. And I wasn't upset, but it just really reinforces the idea that we live in a bubble where people who are following up AIs, they know the values, they know how to use it, they build workflows around it. And then the other group of people who are divided in two groups, those who just don't do anything, just complain and so on. And this is what I'm talking about. If you watch Superman 2025, that post on Reddit reminds me exactly of the Rage farm here. Just the monkeys of Lex Luthor farming outrage 24/7. That's exactly this whole, most of the audience on that group is basically. That's exactly how I see it. So Only an idiot would use an install prompt and let the AI do it. This is exactly it. So, all right, I'm gonna stop talking about this topic. I did pick one of the issues, just one guy who seemed a bit civil and drew my attention to this. And basically, I just pointed him to a bunch of resources. And also, if you're curious about the license, yes, the license is a bit controversial. I don't care. I had a big incident, and so I decided between either doing closed source altogether, just binary releases, or in the middle. And so I made my own license, and I call it HOSL, uh, Human Origin Source License. It's really what it is in simple terms. It's just source available, not an open source license. That's it. If you're curious about the backstory, I wrote a backstory. I explain a bit why I made it and so on, and what I faced and how people these days just simply rip your work and then they say, "Oh yeah, we vibe coded it from scratch." So they steal your architecture, they steal your ideas, and hide behind their agent. Say, "Oh yeah, we're just doing this from scratch." Oh yeah, and so on. So it's a bit discouraging. And hey, this is a manifesto. A license or a pseudo license doesn't stop anyone, but I'm just making a statement. All right. So this is about the trolls, about the background, about the license choice, and I did share some prior videos, informal videos about that technology, how to use the SQL technology. And I shared something as well about ChatGPT work, which I can talk about right now. So, since I already spoke about how, like, just at a high level, the installation step and what you can do and why it's built from sources and so on, um, I simply made an article recently on my big prompt library repo. If you haven't seen this repo, it's a collection of prompts and whatnot. I started this like 4 years ago, something like that, with Lewis here, Lewis Shark. I joined his efforts and then we parted ways, different directions and so on. But basically, I keep adding some LLM related articles over here. So you might want to take a look. And one of them is how to do reverse engineering from your phone. You don't need a computer. You don't need, like, you're not doing remote. So you're not opening your computer and doing like Codex remote or Claude remote or anything of that sort. ChatGPT work does give you a virtual machine and you can read this article. So, hey, I wanted to test it out. We have a virtual machine. So can I prompt, just open my phone and send the prompt? And in the prompt, can I just simply say, for example, hey, this is a binary, this is a reversing framework. Could you just reverse something for me? And if I go on a half an hour, 1 hour walk, I can let my phone do the work for me using ChatGPT work. But by the way, just a quick side note, I don't advise to use ChatGPT work anymore for security work. They're very finicky, you can get banned, so I got a couple warnings. Of course, appeals don't work or anything of that sort. So that would be the last I touch ChatGPT whatsoever and OpenAI when it comes to contributing back to the community, any security work out of the question. No more. So far, Claude and Anthropic seems to be more tolerant. No warnings, no nothing, since all I'm doing is just tooling. But yeah, I got my first warning in OpenAI, so I'm not touching OpenAI anymore. So ChatGPT work, and essentially I went and just prompted it. I said, this is a screenshot from my phone. I said, hey, as you can see, a transcription never gets my last name correctly, or even GhidraSQL and so on. But it's a simple prompt. All I did is like, hey, go to GitHub, go to my repo, grab GhidraSQL, and just build it and test it. I really wanted to test the end-to-end scenario inside ChatGPT work. And again, I don't endorse ChatGPT work or OpenAI whatsoever after this warning I got. So that's the last time I talk about them in my videos. So what happened here is, of course, the VM is not necessarily the best, but it took 52 minutes to build everything from sources, which is very reasonable. This is expected. And after that, it's just all unattended, no hiccups, no nothing. It just figured out things. And I never built my tooling inside that environment, by the way. So it's the first time I work inside this environment. So it did catch build errors. It did give me some stuff to improve this latest version that I'm working with right now. So like some difficulty in the toolchain, especially we are in a VM, and so there are restrictions as well. It's not like your machine, but still, the AI figured out what it needs and gave me some actionable item I can use to improve my unattended installer, to improve my CMake scripts so they don't hiccup in certain environments. But of course, it's hard to accommodate for all variations of Linux and other environments. So still the install agent prompt is the best way to work. And so after it did some patches and fixed install it, now it's ready and poof, oh, here we go. It picked a binary and started doing the reversing. And then at the end, I asked it pick any random binary from the system. So it picked bin/ls, which is fine. It doesn't matter. The point is not like whether we're using GNU tools as a test or not. The idea here is how cool is it that we have something completely open source that an agent can just go grab, build, and reverse engineer. And so basically it picked bin/ls, and which we didn't have the sources on the machine, and just used the GhidraSQL to go back and forth, basically issue a discovery SQL statement. Hey, select functions. Now I got dummy functions, and hey, give me the decompilation, and then let me rename variables, update local variable in this function, rename it to, set the name to, and so on. So a series of SQL statements. And at the end of the day, it gave me back the recovered source code all from my phone running in a cloud VM. And so here we have the ls, which is recovered. That's not the original source code. It's derived from reverse engineering the ls binary on the ChatGPT work virtual machine. Now, real quick, if you're curious about that virtual machine specs, I do have another article real quick. So here you can just ask ChatGPT work itself to introspect. Essentially, we have 9 logical vCPUs and around 24 gigs of RAM, 60 gigs of space. We have a bunch of pre-installed developer tools as well, and so on. And it's an AMD 64 system. So this is what we have deployed, and look at the recovery. This is all done using Ghidra as a decompiler backend and GhidraSQL as the AI connector. And here we have it, type defs, recovered nicely, all the types. That's because GhidraSQL gives the AI abilities to work on the binary with respect to everything. The SQL surface that I designed lets us work with types, manipulate the types, rename members, introduce types, edit types, delete types, play with the decompiler outputs so it can set the function prototypes. Basically, it can do everything. Like the whole surface is almost done. So really, there's not much work for me except maybe improving the speed of stuff and maybe adding a few missing SQL tables. But with respect to the deliverables and the capabilities, Here, I mean, how many times I have to prove it already? I still get people talking trash about the tool, unfortunately. But at the same time, I think it's operator error. That's why I'm making the videos. So if I look at my Vibe RE real quick, there's so many things that basically shows the point. Now I can't share everything. I just make a small gallery here on Vibe RE, just showing some of the stuff. I throw it at the driver and say, okay, give me back the source code and write me a client library. Now, did I ask it to give me the full source code of the driver binary itself? Yes. But did I share it? No. But for example, here, this is fully recovered IO control surface and internal enums, all by the AI using GhidraSQL. And it gives me a user mode library that does all of those stuff. So, really quick, back to the ChatGPT work scenario. Essentially, the recovered LS here is pretty good, like the help screen, the function, and this is backed by GhidraSQL, which is basically Vibe RE, your model here. Let's say we're using, I'm not gonna mention OpenAI, so let's using Opus. So Opus here and your harness could be anything. I'm gonna use the popular one, let's say Claude Code. So Claude Code reads the Ghidra skills and now knows how to get what it wants. So if the model decides, hey, first I want to explore the binary, then it issues an exploration query. Hey, how many functions, how many imports, exports, what are they? By asking the query, what happens is GhidraSQL translates the SQL query to a set of API calls, essentially. And what's my API surface is libghidra. Then libghidra itself need to do the RPC call to Ghidra itself. Ghidra could be headless or UI. And so then libghidra, of course, will do this kind of thing here. So this is not for me. And so here we go. So then libghidra goes and simply does the thing. So it's bidirectional essentially. Ghidra through the libhost, API host, I will show you in the Ghidra UI, replies back to the RPC, libghidra replies back to the SQL surface, and your coding agent, all it sees is just the SQL result. And using only that, it can reconstruct the code. If reconstructing the code is one of your goals, of course, you can ask it to do something else. You can basically talk to the binary as if it's a code base. How does it work? What does it call? What's the relationship between function A, function B? It's up to you, okay? So it's a tool and it's so powerful. You can see, for example, it recovers subtypes, structures, nested structures, the whole thing. And people will ask, is this hallucinated? Not necessarily, because it's backed by the decompiler. So that's the thing. It's we're not just using this assembly listing, which could be, as of now, maybe a bit challenging. I'm not saying it is challenging. Some models are extremely smart. They need assembly listing and they can do most of the work. But if we rely on some algorithmic output, let's say Ghidra decompiler, that's a good starting point, which grounds the model, and so it minimizes hallucination. And of course, now if it's a mission critical thing, you might want to have some verification in place. So usually what I do, I do a secondary pass and look at the source code and have it go again, look at the decompilation. And it's a bit iterative because not only I'm getting back the source code, I'm improving the Ghidra output. So I'll show you normally with OpenGhidra or IDA and whatever, and we rename variables in the decompiler, we add comments and so on. And so that's what we do as humans by hand. So even if I'm recovering source code, it carries over. So I don't have to do by hand to annotate in Ghidra. It's kind of like a recursive loop. We recover the source code and we apply back the source code on the binary. If there's an issue in the source code, then we cannot necessarily apply it in the binary correctly, and so we can find discrepancies and whatnot. But at the end of the day, in my personal time and cases and uses, there's no binary that is compiler generated. I cannot have the source code. So sometimes I give my AI a goal, and let's say a 200 kilobyte binary, and say go fully annotate the database. So we go to the database will look like the source code. And then I say, oh, at the end also give me back on the file system the source files and organize them nicely. So as if I had the source code. So create a make script, was it CMake or not? Refactor the sources, so maybe produce 4 or 5 source code and put them in the file system in different folders. This is some basic ask. And then I have the source code. Now you want the source code, that's great. You want a fully annotated database to do something at the database level, you already got it. What I'm trying to say is you don't have to do anything by hand. If where you spend your time, whether IDA or Ghidra, just renaming and thinking about what is this structure, what are the field names, what is the layout of the structures. This is something we used to do years ago. And now with Vibe reverse engineering and the right models, like the ones from Anthropic, for example, you don't have to do anything by hand. That's all I'm saying. Now, do you still have to do some stuff? Of course, you have to guide the model as needed. Of course, some things you just put it in the prompt and tell it, hey, do this, do that. But I think with as time passes, the window where we have to even steer the model is gone, especially if we have those recursive loops, so to say, where produce something, verify, uh, let's say act, react, loop again, and so on. So that's all I'm saying. That it can self-improve, it can even note down the lessons it learned and use those. Let's say you can ask it to emit a skill or just a simple markdown file and reiterate and re-update the workflow it used and extract lessons learned and generate a bunch of other markdown files. Then at the end, do a final run and produce skills. And then you start with another binary, you have skills which will be improved again, and so on and so on and so on. And really, that's where I think little by little for compiler generated code, things are becoming ridiculously simple. Now, what is left is okay, if the tooling, so if we go back here, it all hinges on this guy, the back end, whatever it is, Ghidra, IDA, Binary Ninja, Radar 2, whatever. That, do they deal with obfuscated binaries nicely? Yes or no? That's the question. Can we add plugins? Can we improve that? But this is not my problem. I mean, this is not the problem I'm solving. I'm basically sitting at the layer of your AI agent here. What can I give the AI agent to have a smooth experience, token efficient, and a large action surface? And so this is where the xSQL technology comes into play. Now you want improvements, you maybe improve the speed, you improve the underlying backend, you supplement it with the obfuscation plugins, or even you can leverage external stuff. Hey, let's use the emulators, symbolic execution, etc. But that's a separate, I really like to look at it as a completely separate boundary, completely separate problem to solve. Once you solve it, so let's say you're dealing with an obfuscated binary, you can, before even, you can take it as separate problem altogether. Take the Vibe RE and how can we use different frameworks, emulation frameworks, our deobfuscation scripts, deal with that on the side, then combine it with the different connectors, just so you can work in 2 or 3 workflows at the same time. Split an obfuscated binary problem into the symbolic execution part or other deobfuscation workflows, and also combine it with the SQL surface. For example, maybe use the SQL surface to set up your environment. Grab the bytes you need, grab the binary layouts and segments, create a unicorn virtual environment, so to say. Let the emulator works and resolve something, get the result back, and annotate it in the database, for example. These are all workflows. Here, I'm not claiming to solve the whole workflow problem, but this is good foundation. All right, so yep, this is basically working from your pocket, essentially. So this is really where it stands. Now I'm gonna get back on topic and talk about practical installation and a few use cases. But all the time I spent in the theory and ranting, I think this is very important concepts that I have to go through, because really it's not about the tool anymore. It's not about Ghidra or IDA or Binary Ninja. It's about the concept and how you approach the problem. Okay, so back to the action, the real action. Basically, so what do? We go, we open our coding agent, and we say something like, something simple. Let's see here. So I started this a while back. I'm just scrolling up to the beginning of the chat, which was a really simple prompt, which was, hey, grab yourself the latest libghidra. And you see, this is just mistakes from my transcriber, which is fine. LLMs are tolerant. Disclosure here, I already cloned those a few months back, and I'm asking it, hey, grab the latest version. But if I am to start fresh, which it's gonna be time consuming, but if I start fresh, so I would say something like this. I'd open, let's say, okay, let's talk about Anthropic. So stay with Anthropic, no OpenAI. Go here and say, grab this and read the install prompt, then configure, build it, and stand up a GhidraSQL PHP server in the background and test it with, I don't know, let's say here I have a shiny sheet driver and test it with this. Then we can ask, tell me how many functions are there. So if I do that, here grab /clone. That's it. That's it. Now that will install Ghidra on your system from sources. And then you maybe, depending on how fast your machine is, it can take up to an hour. But that's a one-step, one-time process. That's it. So here we go. I'm not gonna wait for it. I'm gonna interrupt it. But here it is. The process started. It's just gonna issue a clone. And it's gonna read the install prompt. And then it will follow the instructions. Hey, do I have HDK? Do I have a Ghidra binary? And so on until my system is primed up to run Ghidra headlessly or non-headlessly, and to be able to basically analyze this binary. After this finishes, I would be able to open my favorite coding agents and ask question about this binary, including give me back the source code, or write me a user mode interface to talk to that driver, and write me user mode code to install it as a service, so to stop the driver, and also to discover its IO control codes and know how to leverage them. So this Chinese driver will give me ability to open any process, bypass protected processes light. I don't need privilege escalation. I don't need system. Just enough if I have admin, at least admin just to install the driver, and then any user can just use IO control code to talk to that and have superpowers on the machine, for example. If you were dealing with the firmware for some archaic architecture that Ghidra supports, it doesn't matter. You don't have to be technical. You just do like that, swap the binary here with the firmware, and let the model deal with it. So here we're using Opus 5, for example. Any model would do 4.6, 4.8. They're more permissive, so they would work. So here it is. Now it's gonna simply start the CMake after it cloned it. And this is the dependency. If my system is lacking, it's gonna go figure out dependencies on the fly. So if there's an error, you as a human would not waste your time. Yeah, this error, let me go open Stack Overflow and whatnot. So really, you would have more time to spend than being a rage monkey on programmer humor and just complaining about how ignorant you are. All right, so I'm gonna interrupt this and assume it's done. And then after it's done, at the end of the day, so we'll see here from a prior chat, hey, I got this. And finally, I produced for you GhidraSQL and so on. And now the GhidraSQL is up and I have answers for you and whatnot. And at the end of the day, you will have GhidraSQL executable here. I moved it to my tools. So if I go, so here at the end of the day, if you ask it to give you a release build, then you will have here, I moved the binary. So now it's rebuilt again, great. But this is that's it, that's GhidraSQL. So GhidraSQL, you need it with the Ghidra distribution. So here Ghidra, which is you grab a Ghidra build. The AI, if you use the AI install prompt, it will do it for you. It will grab Ghidra. So I did Ghidra install directory. I put the environment variable to makes it easy for discovery. And it grabbed for me a Ghidra binary, a zip file. I unzipped the zip file. That's what I have. And if you've used Ghidra before, of course, you can start it with the batch file here, for example, Ghidra run, or in Linux, the shell script, and you get yourself a Ghidra just opened, and then you can start a new project, let's say an unshared project. Let's go to demo here. Just let's work here. For example, driver one. Just do that. Doesn't exist. Let's just do that and finish. So I have now a project. The project will be a combination of multiple input files, so to say, related stuff. So if I drop this one here, of course, this is not what I'm going to be doing. This is assisted, but it's an important step of the installation I'm going to be talking about. What does it mean assisted? It means like if you want to have Ghidra open, if you want to have Ghidra open and your coding agent open at the same time, you can. If you don't want to even open Ghidra yourself, absolutely you can. You don't have to open Ghidra at all. But let me show you real quick couple things that will help us make sure everything is installed. Analyze. Yeah, fine. Let it analyze. This whole thing, you don't have to go through, as I said. You let your agent do the install prompt for you, and it can drive it all headlessly. You don't have to see Ghidra at all. But let's talk about an important thing that helps us with troubleshooting. So if the GhidraSQL is properly installed, or at least the dependency, the libGhidra, which is the biggest dependency as we spoke, right? So here, libGhidra needs to be installed. And so this is what we're gonna double check it's installed, because this is what uses this is the RPC part. So libGhidra is composed of two components. A Java extension that lives inside Ghidra itself. That's what we're going to check. And then the second component is the abstraction layer, the API, which is in CPP, Python, and Rust. So to double check that the RPC layer is installed, that's what you're going to do. We're going to go to File, Configure, then Ghidra Core, and filter by lib, and here it is. You need to make sure this is installed. That's what the install prompt would have done for you. Otherwise, you'll have to learn how to put an extension in Ghidra. And if you know me and follow my work, I only recently started looking at Ghidra. I'm not an expert at Ghidra, so I have to look up the documentation every single time. But with AI agents, now you focus on what matters, the problem, not the mechanics of basic installation and whatnot. So for this is already installed, and because it's installed, this is what we create a bridge between the Ghidra Java application and our bridge here, which could be that could work with your editor. That's where you do the programming. So as long as the bridge is installed, here you see that's basically part of libGhidra, the class location. You should put it in Ghidra extensions, and you put the whole jar file. And if it's installed correctly, then you will have in the tools, you'll have a new submenu. And that's the key. That you need this if you're using pair vibe RE. Pair, which means you and Ghidra at the same time. That's the most important terminology I'm saying. So with this, if you at any point you were using Ghidra, then hey, I need AI. I need help with AI. You just simply in that Ghidra instance, you can have 100 Ghidra instances, and you can have 100 RPC channels dedicated to every open database. So here I would say start server, and then I would just simply, since this is like one project, I will just pick a unique port for it. So I'm gonna, and this is important, you can start Ghidra on machine A and bind it to a different network interface than localhost and a different port, which means you can have GhidraSQL or your coding agent running on another machine in a sandbox. So you can have Ghidra, which will not do any code execution, on your production machine, and you can put your coding agent, your AI agent inside the sandbox. And then all they can do is simply update Ghidra database, annotate, read, and so on. And if the agent gets compromised, it's in the sandbox environment. The only communication is the GhidraSQL surface, which is the worst thing it can do is badly annotate your database or delete your functions in Ghidra. Yeah, so what? You can always make backups. But you have the ability to isolate where your coding agent works versus where your Ghidra experience lives. And as well, again, this is not something I am trying to solve. You design the isolation the way you wish. I give you the tooling for that. So this is all I need to make sure it started. Say now, okay, hey, I have libGhidra host running, and here it is. This is it. Now I can take that connection string and use libGhidra just to write scripts if I want, or if I want to use the GhidraSQL. So for example, this guy here, I will have this function here, for example. So if I want already, I can open up here a fresh session. It doesn't matter which folder you are in. The most important part is when you say where or which GhidraSQL, at least it has to be accessible. That's it. You need to know where it is. And then I'm gonna use skills, and I will talk about the skills in a minute. So here, plugin, installed plugins, and GhidraSQL plugins. And so I have to install the GhidraSQL plugin. What is a plugin? It's just a terminology that modern AI coding agents call. It's simply a group. A plugin is a bundle of skills, agent files, maybe extensions, slash commands, whatever. So you want to install the companion skills, and this something is not specific to GhidraSQL or anything. It's just a skill, and that's the repo here. You have to go to GhidraSQL skills and simply point your coding agents. So for example, if you're in Cloud Code or let's ignore OpenAI stuff and focus on this guy here, slash plugin marketplace, and here it is. We just simply add the marketplace. Once we do that, then we have here GhidraSQL tools. Then inside it we have GhidraSQL plugin. It's already installed, you just install GhidraSQL plugin. Once the plugin is installed, in my plugin, I only give you, I don't have agents or slash commands, I have skills. And so those skills is what you want. We're going to talk about the skills. And the most important skill is the connect skill. Now, if you've watched my prior video here as well, if we go to the Vibe Reverse Engineering, the first video, you will notice in the table of contents, which you can also use, basically it's the same step here, talking about the agent skills. And so I explain what different skills mean, and they are the same. Meaning, if you watch the GhidraSQL part and understood the xSQL concepts, you already are there. Well, what I'm walking you through is just simply libghidra or GhidraSQL specific stuff. So the skills are similar to IDA skills. So if we slash skills, next videos will be about R2, Radar 2, and also about Binary Ninja. And the difference would be in this column here. You would see R2 xSQL, or you would see BN SQL, or you would see IDA SQL. But then the same skills, analysis, annotation, connect. So what I'm teaching you is a bit repetitive, but if you just started watching today, you are getting the prerequisite equally. You don't have to watch IDA prior video. But so the most important skill is connect. That's the first skill. That which lets us start Ghidra either headlessly or in pairing mode, pair mode. So if I go back, let's see here. So this is my fresh session. And by the way, here I'm using CLI. You can use UI if you have a chatbot. You like user interfaces. Go ahead, use it. You want to use, let's say, GitHub Copilot app. Yeah, go for it. If you want to use Cloud Code desktop app, go for it. So if you want to use this cool application, it's the same. It supports skills. Just open it, have a nice UI experience, create sessions. So you can say I'm reversing driver 1, reversing driver 2. Everything works the same. Or if you want to use Anthropic products, so Claude, let's say Cowork, and so on, or even the Claude desktop app, it's gonna be equally the same. So it depends what you like. So here is Claude and Anthropic products as well. Cool stuff. They don't give you warnings or let you talk to a robot for nothing. All right, so I have the skills. and I have started the server. So at any time I can double check, I can say server status, and this is basically it. Now, all I have to do is connect, just connect and give it that. Then we can start the query. So for example, how many functions do I have in this binary? And now what we are working with is this guy, this binary. And because I explicitly gave it a connection string, it doesn't have to do Ghidra headlessly. It's gonna just simply use what you have. So here it is. It's just immediate. Hey, you know, I connected to this. I'm bound to this Chinese driver. It's x64 and it has 45 functions. In fact, here you can see all the functions here. All right, what can you tell me about the driver entry? So, for example, in this case, I'm just doing this pair reverse engineering. And now we can see what it's doing is mostly SQL surface. So everything is SQL. It's gonna say, okay, hey, I'm gonna grab the pseudocode. So select text from pseudocode where function address is 370 here, which is basically that function, and then it's analyzing. So the decompilation was done. Now what's just is the model spending time. So the model now grabbed the disassembly. It first got the entry and then it followed that, and now it grabbed this, and it's simply reasoning about that. That's all it's doing. And so the time we're waiting on is not the tooling. GhidraSQL already finished. So hey, connect vibe RE uses the connect skill. We said connect skill invokes GhidraSQL. GhidraSQL knows connect, issues a simple select star from binary, goes to libghidra, talks to your user interface here. It gives it back a summary of the binary. Then the connect skill itself asks some introductory questions, how many functions and what's the binary name. And then that SQL as well goes all the way, goes to your UI instance through the same connection string and gets back the results. Then we say, okay, now decompile, select star from pseudocode, then converts it to APIs, remotes it, and travels all the way back 3 layers, goes back, gives the result to your model and harness. Your harness now syncs and reasons, and when it finishes, that's what you get. So it finished reasoning, and here it is. Say, okay, I have the driver unload and the create handler. So now, for example, if I list the skills again, I have so many skills like data to work with data, like disassembly, strings, and so on. Decompiler to teach it how to talk to the decompiler, what are the optimal queries to talk to the decompiler, how to rename local variables, and how to apply types, recover types, and whatnot. Functions, cross references, type recovery, and so on. So, for example, we can use the annotations here, and would you fully annotate for me the decompiler output of the IRP MJ create dispatch handler, and also use the types skill to recover the types and applies them in the decompilation. So for example, I asked it, now do I have to use the skills? Not necessarily, you know, models are smart. They can dynamically figure out the schemas. They can dynamically figure out the views. But it will be wasteful in the sense that we don't want the model to discover every time. What we want is to give it pre-baked recipes that are token efficient and also with optimal queries, because I spend a lot of time making sure certain kinds of custom views, pre-computed stuff are optimal. So simply the model is reasoning. Now again, this is just the base. What I expect from serious users, not rage monkeys, but serious users, is to build their own skill library. So if they have a same kind of workflows, to ask the model at the end, hey, jot this down in reusable skills, because this is the basics. I'm showing you from a fresh system here. But in my own workflow, it's much faster because it doesn't have to learn everything each time. Now, after this, I can compile at least 5 extra driver specific skill set that will make it super fast to analyze future drivers. So right now, for example, it's just checking if there's any types installed already. If there's nothing, it will try import them or introduce them and so on. So let's see here. So the types for that driver, there are not many. Eventually, it will introduce types specific to that driver at the end of the day. And because I ask it to annotate, it's gonna be slow because I think I have a higher reasoning model. The effort is a bit high, so it will take some time. But it started. You can see here, it started to introduce the proper types. So we can see empty status already there. A IO status block is introduced. Device object is already introduced. Here it is. So it found the IRP, IO status block, device object, and give it enough time, it will figure out everything. So let's see here, just while it's working, what's happening. So yeah, the driver entry is like that. It creates the device with its symbolic link here is Facebook media. So this is if we want to interface from user mode. We use create file to open a handle to this DOS device. And it's still reasoning. And I asked it to annotate. So what we will end up with here is a full annotation of this driver here. We will get the whole thing. Nicely applied, no more dummy names. And then I can use, for example, the /goal. And then I would say use a resource. So there's a skill called resource, so to give us back the sources. It has some strategies for source recovery. Nothing fancy, just English and prompts. So it's basically recursive bottom-up source recovery methodology, annotates, and so on. It has to use a decompiler, annotation type, recovery cross-references, and whatnot. And it just tells the model, now again, give it a few months in the future or few couple years, this will all be baked into the model, or maybe a dedicated harness. But the tooling I built is a good foundation, is a very good foundation. All you have to do is adopt it into your pipeline. I'm just one person. I cannot solve for everyone and so on. I have just limited capacity building this hobby project, which is already way more powerful than just a hobby project. So when the model finishes, eventually it will do the whole thing. So already we can see structure offsets resolved. Now let me understand. It will map out the model I'm using is very powerful, and so it will map out everything, and it will eventually annotate everything for us. So Just to quickly speak some background as well. So this is why it took me some time to really demo those toolings, because the time spent is waiting on the model essentially. Uh, and so I let the model work a bit. I'm gonna show you some of the results. It's still going. I will not necessarily wait for it until it finishes, but I will be discussing what has been happening so far and just show you the quality. And if we give it more time at the end, you will see the end results. I will explain. All right, so back to it. A quick recap. We started with pair reverse engineering. I because it's pair, so I am not doing headless, so I have to manually start the libghidra host, and then now I can say connect. So here I can connect to a specific Ghidra user interface, and once I got success, I say okay, this is what I'm looking at. It detected the driver name. Then I started talking to it. It detected some things, and then I gave it a goal, um, and let it start working, use annotations, skills, and whatnot. And it just kept iterating, and full summary of the dispatchers, and so many things happened behind the scenes, and it finishes. So let me ask a bit. Just give me like a bunch of queries that you've issued, and just to get the understanding, like just like categorize the different GhidraSQL queries that you had to use, and the functions you discovered. So let it do some self introspection just to discuss some points I want to make. But meanwhile, we started with a non-annotated driver whatsoever, and I let it work. I just gave it a slash goal, and I asked it to annotate and do all those stuff. And so, for example, if we now go back to the driver entry or entry, which is the entry point, IO create driver, driver entry. And look now what we have. We have a nice driver entry. We have nice annotations. And here it did realize, hey, you have decode XOR obfuscated device name. Indeed, I was looking, and already look at that. We have nice stuff here, all nicely annotated. Undefined, it's fine, you know. I can prompt it again. Hey, give a proper prototype for those two guys. This is the model itself did simulate that piece of code here. It did a simulation. It figured out what the device name and the DOS name. So here I think there's the call to create device. So there's the device name and then the symbolic link name. It managed to simulate both decryption routines, and then it applied the proper driver object. It put the dispatchers and renamed most of the functions. This is what reversers do, right? And then I can follow, for example, dispatch create. Look at that. This is a whole dispatch create, proper stuff, applying the types. Let's go back. So this is all GhidraSQL and the model, of course. Here is still, so you see, I asked it just in a bit here, like self introspection. It's gonna do something interesting. But meanwhile here, let's go back. So let's say IO control code. Here it is. This is IO control. It figured out and introduced IO control codes and all the nice stuff. Now here, this is where it becomes a bit philosophical, I would say, or borderline zealotry. Oh, IDA's better and this and that, and they start trash talking, unfortunately. Uh, I'm not gonna be political about this. I'm just gonna talk the end result essentially. Even if you don't like Ghidra, um, if you massage it correctly, you can get good results. If you let the LLM massage the output and exercise Ghidra, you get good results. So for those IDA zealots, just take a seat a bit and be open-minded. Sorry. So let's take a look here and keep looking, just sample things. For example, discover the functions, get kernel module base, get module base. We can ask it to do another round and improve the situation even better, add more comments, recover the types here, request buffer. So this is what I did offline, okay? So we are already in a good spot here. Uh, let's ask here. Okay, can you show me on screen without the artifacts? Uh, so I've done this offline, and I ask it to go all the way. All right. So let's take a look at the end results after we had a nice annotated database and get the end result. What I ended up with is I asked it to give me back the whole thing. So this is the binary I started with. Give me a user mode component and give me the full driver with a CMake script. So it built me a CMake script to build the driver, and then it reconstructed the driver based off the Ghidra decompilation. So here I think in a second round would improve the driver much better. We'll have extremely way cleaner decompilation output. Definitely, we can recover more stuff just another round. Again, this is where you come in, make a better workflow. But if I just look a bit at the results, as the driver, let's judge the output here. So we have the IO control codes. Are these hallucinated? No, they're not. They're coming from the decompilation. And structures, nicely recovered. Like, you don't know that this is not the original source code. And then these are all the stuff lifted. Let's take a look. For example, okay, create close. This is what we see here. Create close, essentially. Unsupported, pattern scan. I don't know if at this time here, pattern scan, this is the pattern scan function. Is it hallucinated? No, it is grounded in the decompilation. It mimics the binary. So again, sometimes you can judge quickly, but let's talk reason here. Pattern scan sections, very clean code, query system info. Now this is in the domain of vibe coding. Now I can actually work in this source folder, refactor the code base, reshape it, clean it up more, add test cases and whatnot. Find module base, find NTOS kernel pattern, how to find the image base of this one, find PFN, read physical memory. So if you were always curious how to do this from the driver, well, it's really showing us. And I think these will be mapped to the device IO control code eventually. Where is this? Find. I don't know, something wrong with my editor, but yeah, like translate virtual to physical, get the PML for entry, page, table entries, page directory entries, do the parsing, convert from PTEs and so on to virtual memory representation. This is basic constructs, meaning they read the Intel manual, figured out those at CPU structures, and just they are re-implementing them in the driver. Now, if this was obfuscated, you deal with the obfuscation first and come back. I get people asking me, yeah, I have a VM protected binary, I have this, I have that. It's separate category. I'm not talking about those stuff. And it doesn't make GhidraSQL any less powerful. Whether we're dealing with obfuscated or not, that's a separate problem. Go brag elsewhere. Handle read memory and so on. Now the cool part is we started with a driver. Now I asked it offline, give me the user mode counterpart and look at the nice client library. So now if you're a user mode counterpart, we open the DOS device and these are all the IO control codes. And so it gave me a client library. It redefined IO controls. This is where I can tell, unless this guy is including the same user mode or replicating. So yeah, I can say refactor the IO control codes. So make a common folder and refactor both this into a common header file between the user mode component and the kernel mode component. And so just quickly, here it is. These are the IO control structures, which are also common. These are common. I would also say refactor those into a common folder instead of repeating the structures in a disconnected manner. And then it gave me a demo. How can I use the driver from user mode? So here, read PE header and find entry point. Let's see the main function. Main function, okay, that's the context, enumerate processes, fine. All right, open a context, attach context to process ID. Now this is read the PE from the kernel, it seems, and so on, and like do some writes, which will eventually go to the kernel, and this is all going through the kernel. So if you had some magic protection on your process from and so on, now this driver can be used to do those low-level stuff. Bypassing user mode API, no read process memory or write process memory, open process handle, nothing of that sort. So like just to scope out a bit, have the model introspect, what did we deal with? So for example, just like what happened through the SQL surface. We had a bunch of work done. Of course, again, if we look at here, we can see some of the stuff I let it finish. We added heading comments, nice local variable renames, prototypes, so type application, type recovery. I don't know how many types it recovered here. So these are like, I guess, the types, the custom types and the program itself. So these are the drivers custom types. It recovered them. And that's what we see at the source level. The types, we have the struct somewhere. This is recovered. So initial exploration, select from binary, function count, reading surface if I want to decompile, renaming local variables or reading local variables, updating, setting prototype, update the functions table, introducing types, verification, search and discover all the cross-referencing part, and so on. And that's how it did what it did. Now, if I wanted to do the same thing completely headlessly without Ghidra, so if I close this and pick some toy binary, let's do that. So here I have another binary, let's say this guy, and let's make sure I don't have any Ghidra open, no Ghidras. All right, I can say same story. I can now completely headless, okay, no Ghidra involved. I can say connect, open GhidraSQL, HP mode, keep it in the background, use, and let's give it this new driver here, and tell me how many functions it has. So this is now fully headless. And let me see if I take just a bunch of other binaries, just to show you the scenario of multi-binary analysis. Just take a bunch of them. Nothing really, there's no limits. So here as well, let's isolate a bit. Let's move those new ones here. Let's call it test2 and maybe start over here. So I can also say something like connect. I use the driver files here, open GhidraSQL headless in the background. Show me a table of how many functions there are. I should have deleted the code from the prior demos. Let's just so /connect. Open the drivers in this folder in the background, and in the table show me side by side how many functions there are. So for example here, I'm simply analyzing multiple drivers. So if I go into test2, we're gonna be using Ghidra 4 times and 4 headless Ghidras, and I'm doing 4 at the same time. Meanwhile, this is a single instance here. What was the results? Yeah, we have it. All right. Decompile the main function or the driver entry and show me decompilation. Keep GhidraSQL open in the background and manage it. So for example, here, keep again transcription sometimes. I think it's already open. I didn't see where it is. But here now is doing all right. It finished here, 4 of them at the same time. Okay, now add one more column to the output and show me as well the largest function of each. For example, like multi-binary analysis. Of course, these are silly questions. I can say, I don't know what's the relationship between them, anything you want, essentially. But what I'm showing you here, it's managing 4 binaries at the same time. So all 4 running in parallel, and eventually we'll get the answer. Of course, we can do the annotations, we can ask it to rename stuff and save the database and whatnot. Keep GhidraSQL open in the background so we can query continuously and manage the GhidraSQL HTTP instances in the background. So just to make sure here, it's keeping them managed. We will talk about the processes here, the shell. Sometimes I see the shell, sometimes not, but basically we will see here like the server running in the background. We can kill it if we want or keep it open. Maybe we'll see it, maybe not. Here I didn't prompt it correctly. I think it was doing one off. So now it should basically keep the server open once and for all. And that's what you want. You don't want the server to come in and on each time per query. You want your coding agent to start the server and keep it up. So keep the headless Ghidra open all the time. So here all server launches returned, waiting until the analysis is done. And eventually, once it's idle, we'll have 4 instances running in the background, ready for inquiries. Then we can say, hey, save and shut down all of them, and you can just wrap it up. All right, waiting for analysis, and eventually we should get the results nicely and done. So here, a single driver, completely headless. Could you interpret that ACL string for me and tell me what this permission mean? And how many dispatch functions the driver object, what dispatch functions does it register? Which we can see here, at least there's one dispatch or two maybe. But no, I haven't even asked it to do anything extra like annotate or rename and so on. So it's almost like operating read-only mode. All right, let's see here. Okay, so for example, here it is. These are all the different background instances up and running in the background, and I can ask as many questions as I want. Okay, add one more column and show me how many strings each one of them has. So now I can even further the analysis, for example. So here it's very simple. For every one of those different drivers, which are operating at different ports, I'm doing count star from the strings. And I got the strings. All right, and one more column, show me the longest string per binary, and show me the actual string itself. And tell me more about this leader driver. What's interesting about it? Use a separate agent to analyze and answer me. So here maybe this driver is special. I don't know what it does. We can ask it to do use a separate agent to answer in parallel, for example. And here is trying to compute, just trying to get the length of every string. That's a bit of a heavy query, but it will work. And here I asked to analyze that driver. So here we can see it opened a secondary agent. I can use the cursor keys here to hit enter. And it opened a secondary agent and gave it the initial goal. This is, you are using GhidraSQL. This is the port for that binary in particular. And your goal is to do preliminary assessment. So get the introduction about the binary, scope the imports and exports, scope the strings. And this is how the model gets a quick initial assessment. Try to get the 10 largest functions. And so it's doing this job. We can go back to the main discussion here. And for example, here I asked about the top lengths. Okay, so let's say, good. So it seems all of them are revealing their PDB string and where they build the driver from. Interesting. Let's see here. What about the median size string instead of longest? Add one more column. And feel free to use Python scripts on the side to help you compute faster. So here as well, based on your experience, it's best to invite the model to use coding tools. Is much more efficient. Doesn't mean has nothing to do with GhidraSQL. It's up to you as an operator to optimize. If you notice a recurrent pattern, if the model is not smart, you can guide it, or just to be on the safe side, you can guide it. Hey, but here apparently it is getting the lengths first, then using Python to do the median computation, which is way faster. You don't want the model to reason about mathematics and so on. So invite it to use Python snippets as needed. This has nothing to do with GhidraPython or IDA-Python or anything. This is just using coding tools. This is something from years ago where AI companies started giving models coding tools to compute faster and answer results accurately. So for the median strings, for example, we found those. Okay, let's focus on the ASR driver. I'm very curious about if it uses any registry functions. And for that BIOS tool common driver, does it also use registry functions? And by the way, the other agent finished here. We're doing here 4 driver analysis at the same time. And this guy now finished assessing this cryptic driver. It says textbook, bring your own vulnerable driver target. Every IO control has validate only the buffer size, zero validation, and so on. Now, here, this is where I would take it even beyond anthropic models, go to fully uncensored models, so that we can ask more serious questions. Yeah, we can't necessarily use American models for serious work without getting flagged, whether even if it's anthropic or not. So I don't have DeepSeek here to use or Kimi, but these are things I would take and do more serious work beyond the point of toy examples. All right, so yeah, clear picture, no registry keys at all here, blah, blah, blah. This driver uses this and that. Okay, so for this BIOS tool driver, what are all the registry keys that it touches? So in this example here, for example, we're asking it to do more stuff, just to go deeper. Now, am I a reverse engineer? Let's say, like, do I have the technical skills? Let's say I don't, but I have the higher level skills. I'm asking questions. So if I'm a programmer today with GhidraSQL, I can approach this as a programmer because it feels like I have the source code, so to say. Now, I didn't say, hey, give me the source code, but it's discovering on the fly. And it's using the relevant skills and tables and whatnot. So now it's checking from the strings ref table, doing some quick analysis. Now it wants to answer this question. It seems it needs to decompile. It asks the decompiler to do some stuff, another decompilation call, and then this is where the model decides what needs to be done. It really sucks that this kind of simple stuff are considered dangerous by the frontier companies, honestly. I'm not weaponizing, I don't know, like if this basic work, because this is my profession, right? If this kind of work, I need to take permission from leading AI companies, what's the point? Write websites and make front end stuff. What's the point? What's the point? Shame on you. Shame on you. So yeah, so what are the registry keys? These are all the registry keys and whatnot. And all right, let's one more example just for fun. Use the cross-reference scale and find me the path to those registry functions. Map it out, nice ASCII art from driver entry, even function callbacks. Find the path and show me how the registry functions are accessed. Now, again, let's see. So it should be able to find relationship now using the cross-references table and all the related helper views. So I have a bunch of views and it should optimize on that. It's not gonna brute force manner. It should pick the proper views, sometimes parse the disassembly. So here this is what I'm talking about call graph edges. So I spent time making sure common use cases are optimized for. So finding relationships, uh, call graph stuff, cross references and whatnot. So they're not time consuming and they are token efficient. So here, for example, we have like a big joints, call chain even. So this is something I optimized for. And let's see the result. I don't know. I haven't Like I build the tools, I have some use cases, but I'm sure if you adopt the tool and you give me constructive feedback, I can improve it. So it's still building the edges. So here we can see as well consulting other tables, again, still the core graph edges, doing joints and whatnot. Imagine doing this with Python, right? Either Python or MCPs and stuff. There's no composition. And you will notice the query is instantaneous. Where the thing is happening is simply the model reasoning. That's all. Now, if I happen to work in a AI company that have unlimited tokens and fast inference, this will be child's play. Um, but just from the outside, this is what I can do from the outside, really using a very simple AI subscription. So here it is, it's still computing. It's even following the data cross references as it seems. Well, this question was a tough question because it really has to answer me, find me relationship from driver entry all the way leading to registry key manipulating functions. So we can see here, even had to follow the IO control pointers, which are registers and not called directly. They're registered in the driver dispatch, the driver object. So it follows the function pointers, which it deduced from the decompilation maybe, and then adds them to the queue for discovery. So it's just discovering one thing after the other. And at the end of the day, we will get a nice drawing if it found such a relationship. Meanwhile here, yeah, I've been working with the radar people, so hopefully we'll get R2SQL up and running soon for the same workflow. Essentially, if you don't want to use Ghidra or IDA or Binary Ninja, you can still use the same concept essentially with R2 and so on. Let's see here, maybe should start dropping it up. It will finish eventually. Anything else worthwhile mentioning for GhidraSQL? So I did cover the collaborative mode where you open Ghidra and then start the libghidra host, so you can use a user interface and the AI agent at the same time. Here it is. And also I showed you multi-binary case, so we can do multiple binaries at the same time. Like this session here is 4 binaries. So here it is. How do we access registry keys? Find me a nice ASCII art illustration. Here it is. Entry, driver entry, create device secure, blah, 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 indirect call, then goes all the way, access all the registry keys. Now, what you can do as a user who works in security, what you can do is simply ask it to write a report, to write a markdown file. Okay, so for this driver here, let's use a markdown file called reports dash BIOS tools, for example, .md, and jot down that discovery you've done and that nice ASCII art. Let's see the transcriptor here, if it does well or not. Well, I spoke correctly. So yeah, English is not my first language. So transcriptors have difficulty understanding what I say, but they're very forgiving. So this is where you start building consistency. This is where you start maybe creating your own workspace, a set of markdown files, one for journaling, one for memory, one index file, and one markdown file per specific subsystem. Say if you're learning about your target, you want to know about the I/O part, about the file parsing part, say if you're doing deeper analysis, and so on. So here it is. Because I mentioned the word report, models already have a lot of understanding what a report means. So they will do, I didn't say do this header kind, do this style, but models have training, so they will lean on the training. Let's see here. So just mentioning the word report, look, automatically says analysis, this and that. This is the IO control surface, and so on. Okay, so for example, let's say I want to do something even less of, let's see here, HVEXE. Some people do hypervisor research and stuff. Let's see. I don't know. Let's take this guy. Let's take this guy. And now I can say, so already, this is many. Remind me, how many binaries do we have open right now? Just to show you, right? We have 4 binaries, but just to show you. And it's all headless. And if I want, I can flush them to disk and have the Ghidra projects so that I can open them graphically, keep working graphically. If I want, I reconnect. So, all right, let's do that. Save my projects and cleanly shut down the servers and tell me where did you save all the Ghidra projects. Now, I hope, of course, here, demo gods, I hope it knows what I want. And also, it could be something I didn't say initially. I intend to make changes. So we'll see. Anyway, we can see it's doing a shutdown. So this is something intentional. Every one of them will be asked to properly shut down. That will terminate GhidraSQL headless host. And again, if you want to visualize it, it's simple. After we can say connect skill will start the GhidraSQL process. That process internally will use libghidra, which knows how to open headless. It will invoke Ghidra batch file, which will run Java, and instruct it to load the libghidra host Java extension at a given port. And now when we set connect, Ghidra becomes, which statically links with libghidra, becomes the permanent connection with the headless Ghidra, which you can run headless Ghidra. And when we ask connect to shut down, what it's doing, it's also using the shutdown endpoint and reaching this guy to programmatically tell it to stop the Ghidra headless cleanly and save the project. So let's see. So I didn't say where to put the projects, but I picked the time. That's where, if I prompted it correctly, I said, hey, I started to say connect. I have 4 drivers and do this for the 4 drivers. I didn't say where to save them. I didn't talk about permanence. I could just explicitly say I can today just say move those guys somewhere else, So it would say if you want to move them or reopen them later, etc., I can just go and pick them up. But I will. But I'm gonna show you, for example, I shut all of them down. I could have kept all of them open and add one more. So I just say connect and open GhidraSQL HTTP in the background. I intend to headlessly analyze this binary. And this time, let's put the project folder in this location, for example. And we can demo, let's say, HV analysis. So now I'm doing this hypervisor analysis, and that I don't have to be an expert. I open the binary, I'll just talk to it. Hey, do this, do that, etc. And so we can see the basic invocation, GhidraSQL. Where is the Ghidra header file, the installation binary, where's the Ghidra that you're using. This is the project folder for persistence. This is the project name being created. Now I can then ask it reopen a project. So we can start fresh or we can resume. And then it automatically assigned the driver. And now it's importing it completely, doing the whole thing headless. If I scroll here to the background management, now we see it. Here it's waiting for the Ghidra headless to respond. So it's just giving it time to analyze the binary. So this is a large binary. It might take a few minutes indeed, but it will respond. And then we have ourselves a headless analysis session, which then at the end, when I'm done, I can say save and shut down. I can open the project and continue graphically. In the first scenario I showed you, just open Ghidra if I wish, or come back and keep working. So apparently, yeah, it is big. It's gonna take some time to analyze, and this is an old machine already. But let's go, and it seems those guys have been not saved or deleted. All right. So this is the Ghidra projects of those drivers that the model decided to use because I wasn't explicit. I say just analyze them. I have a quick question. But let's try something, okay? So these are the 4 headless drivers I was analyzing. I did not ask it to do annotations. It will be dummy analysis. I never said anything about annotate and rename, nothing of that sort. So I won't be surprised whatsoever if they're gonna be just simply empty projects that are analyzed, and that's it. All right, let's see how to do this. Again, forgive me, I'm not a Ghidra user. Let's try open project. Okay, so we need to give it, yeah, that should work. At least, you know, it will be analyzed at the minimum. Did I say annotate? No. Did I say rename? No. But I could have. But just to show you, like when we drove it completely headlessly, it did the headless, it did everything headless. Now, if I want to reconnect to it, so let's say even whatever session, right? I can say just connect, and let's hook this up again. Tool, for example, and let's just give it some different port here just to be safe because I don't know how many instances I have. And now it's gonna connect to this guy, and that's like a project I had. But since I'm doing the HV already finished here, and it must have created the project here and the location I wanted, which means I can do what I want in that case. So I can start analyzing it. This is the Microsoft Hyper-V analysis. I don't know if Ghidra supports PDBs or if it picks them up. Do you know if PDBs were applied? Do we have some symbol names or something? This is where your Ghidra experience comes into play. I know in IDA it will automatically detect the PDB. If it's public symbol, it will grab it and apply it automatically. I'm not saying Ghidra is weak or something, I just don't know. But with enough Ghidra experience, this should be child's play. You should be able to do stuff easily. So yeah, then I would definitely apply the PDB since it doesn't ship symbols. So if there's no PDB whatsoever, even better, you know, we can do the analysis. Find me the median function. Or you know what? Let's make it interesting. Find me the busiest function. So use the xref skill and find me the function that is most called. So here, for example, complete blindness, no knowledge, no foreknowledge of this binary, never opened this before, and supposedly no PDBs. What can we do? So I invited it to use the cross references because it has optimizations, so it should be able to answer this question relatively fast. I'm saying relatively. It's not an easy question, but we'll see what kind of query it does. Especially that the analysis is finished, so it could be a bunch of API calls, but it should be able to pull it in a reasonable time. We have to go, that's how it answers the most called function. Normally, in IDA parlance, we have to go for every function in the binary, and then we have to, it finished quickly, right? Then in IDA, for every function, I have to count the cross references for every function and then sort them. So here, for example, okay, so what can you tell me about function number 7 here? Maybe if you decompile it real quick and do some scouting, give me the gist of it real quick. Don't spend so much time and don't do it recursively. So here, very simple scenario. I'm kind of digging into the middle of the binary. I haven't looked at it, and I'm not using any UIs for that matter. So just completely headless, which is fine. Again, if I want UI, I open it on the side. All right, let's see. That thing says all this is, but let's see here. It's a big function, no? Let's see. What is this? Callers. No. If it's busy, doesn't mean it's big. That's why it answers fast. Yeah. Do we have any correlation between the size of the function and how busy it is? Not necessarily those functions, but I'm curious if the largest functions, how busy they are. Let's do that. Let's do another table where we can see first the largest functions and just see how busy they are. So the most called top 15 largest functions. So now here is a bit of, let's see what is the biggest function and the biggest 15 functions, and among them, who are the most busy. So now we have another interesting query, which is a composition. Again, it's a single query. People keep asking me, oh, I use MCPs, I use this, I use that. Yes, you know how much code, how many MCP calls. You don't have composition again. So here it is, a single query. The GhidraSQL will do all the computation, and then the model has to do the analysis. All right, so we have one big function, one caller. Sort them by caller count. Not caller, caller count. So now we're gonna get the same thing, but at least I can see the correlation between the size is gonna be secondary. The callers will be, so probably I'm interested in this guy, number 6. See what, that's a fairly large function called 6 times, who knows? So this is it. All right, so for function 1 here, I'm extremely curious about it. What can you tell me? What's the gist of it? And use the decompiler skill as needed. So here now, it's targeted analysis. It's gonna pick up that function and simply tell me the gist of it using the decompilation. And so as well, because it's large, it emitted the decompilation to text file. So I keep people asking me, yeah, but how do you deal with large functions and whatnot? I say we treat the same thing as a coding agent dealing with a large code base and large functions. So if the model decides we are dealing with a large output, it's gonna use a file and then get chunks and views into the file. Okay, so what is this function here? The gist of this function. Interesting. Look where we ended up. We ended up in x86 instruction emulator. Very nice. Cool. You know what? Let's start documenting in a markdown file. This is an interesting function. We're not gonna dig deeper into this function yet, but at least give it a proper name. So update the function name for this one, and maybe focus on how, and show me as well how it emulates the push F and pop F instructions. So here we're gonna be simply looking at a very simple snippet of that emulator. I'm just being curious. I don't look at assembly. I know no low level stuff. I picked a binary and I'm just looking at the binary as if I'm looking at the code base without an editor. And so you see this kind of analysis. I said I'm not going to talk about OpenAI stuff, but you can do the whole thing from your pocket, from your phone, until you get banned or something. That's a different story. But yeah, you can do that. And you don't need a computer. You don't need anything. You can use the VM provided. And credits where credits due, you can equally do that in Anthropic's products as well. Yes, they give you a VM and you could do the same. So here now we're kind of focusing on a function. We started using Markdown files or whatever memory system you want. It doesn't have to be a Markdown file. And with this approach, with this workflow, I can systematically start my research around that binary and understand the hypervisor fully. And if I want, I can get the whole source code again. I showed you how, and it's no different than, again, one more time. So I do have my own driver research. So just picking something I've done earlier. Here it is. It's a random vulnerable driver with which I have recovered the source code. There is no different whatsoever from recovering the snippets you want in high fidelity. And then, you can find bugs. If you don't want the source code, so many people criticize, you just have nothing but complaints. You don't need source code. Yeah, whatever. And so, basically, if you are doing this kind of research, you clearly have snippets, you have C files, you maintain those snippets for understanding, for replication, proof of concept. So you can have the snippet, you can have the whole thing, who cares? You can do whatever you want. So let's see here, it's focusing deeper and is eventually gonna give us the answer about that kind of thing. Okay, it did the analysis. It apparently, okay, here it renamed the function, and again, if I can afford it, I will just do /fast, but first I'll be flagged, and second, I don't want to burn my tokens. But yeah, if you have the privilege, good for you. I'm just here writing tools and hoping I don't get banned. All right. Maybe next time I'll just focus on Chinese models altogether and stop complaining. But yeah, this is how it is, and that's how you can drive most of your analysis. And the real world, say if you're a Windows researcher, 99% of the Windows stuff, whether they are privileged processes or kernel mode components, you're not dealing with obfuscation. You're dealing with pure compiler generated code. So if we want to sort the most interesting parts, maybe they're no longer bigger than 500K or something. Let's see, NTDLL is the most reversed engineered binary in the world, and you have symbols. So that's the easiest target. You can get its full source code. You can index everything, have semantic understanding in like a day, just a day, and maybe a few $100 in tokens. That's it, Chinese models. You can get that. All right, so we can increase the timeout. So this is something as well I did add. I should have prompted it. I'm doing this on the spot, right? There will be issues. I will be improving the tools. I'm not concerned here. The methodology is settled. The approach is settled. It's a matter of scaling. It's a matter of refinement. I'm a generalist. I don't do specific research. I look at the problem. I try to solve it. I take feedback. And I take tons of shit and criticism, unfortunately. But I would love to have more constructive feedback instead of just shooting me down or ripping off my work. If you like my work, support me, hire me. Um, don't ban me, I don't know. But I would appreciate that more than constant attacks and bullshit. So yeah, for timeouts, I'm sure I remember recently I had to add timeouts somewhere. I don't remember, but let's try this feature here. If you don't know, you can do /dev, and you have a Visual Studio Code editor. Then you can do Ctrl+Shift+F, and you can say timeouts. I don't want to log in if it's not logged in already. I see here timeout. I think I should be able to increase the timeout. Yeah. Mm, okay, yeah. So these are runtime settings. I could prompt the model to, and some skills will tell the model to increase the timeout. So here through a Pragma, I can improve the timeout. So this is the mechanism, so it doesn't hang. That's all. So we can recover nicely. Uh, it should know better. It's fine. I could have just told it increase the timeout. So the thing is, we can always get familiar with the tool, then plan ahead. This is a large binary. There are large functions. I should know my timeouts. I should change some default runtime settings. For example, like I added some stuff so it doesn't hang, like query timeout, how many concurrent requests, and so on. So at least I would talk to the model to update, so set the runtime settings, Pragma, GhidraSQL, here for example, increase the timeout. If it's gonna be large binary with large functions, increase the timeouts and so on. But it will get it. I don't want to do brute forcing. I will just wrap it up for today. I think this has been probably that will be the only video on the topic unless I make something extraordinary. I think next time just focus on libghidra for programmers, not necessarily vibe reverse engineering, because what I was just showing you is really vibe reversing. But for maybe the next time, we're gonna talk about libghidra in particular. And then after that, I think a good scenario is how we can combine additional tools. For example, WinDebug agent, how we can use WinDebug at the same time. And with our analysis, or even PDB SQL at the same time. And so on. Like there's so many tools. I can show you how we can use all of them together at the same time as Ghidra and IDA and Binary Ninja and all of those at the same time. All right, so let me hit escape here. It's okay. Let's wrap it up. So save the project and properly shut down. So let's just wrap it up. It will save. I can reopen the project, maintain the changes I've had, so I can continue later. This is important. You don't want to kill the process. You don't want to kill GhidraSQL. You want to save it. Where did we write hx analysis? Okay, so this is the project. This is the markdown. You could spend weeks, refining those stuff. So here, for example, this is the function. And also there's the strategy. You can make your own strategy how to approach this. You want one markdown file per function. How do you want to index your project? So GhidraSQL, as it stands, as I said, it's a foundation. You can build workflows around it. You can build a product on top of it. And I can help you do that. Let's work together. Anyway, so yeah, like that's a preliminary understanding. We can improve it. We can say, okay, I recover the type here, rename this, do that recursively. You know what I would do? Unleash an unrestricted model on the binary, let it fully recursively use the resource scale I spoke about, this guy, resource scale. It will rename everything for me and so on. And that's a good base. So if I'm gonna, before I go to bed, hey, model, do this. I come back, 4,000 functions already primed for deeper analysis. So we can iterate more and more as we do the research. If it's a hypervisor, that's my specialty. I'm gonna spend time. Some people spend years just studying bits and pieces. Now all you have to do is just get yourself a permissive model and the right questions and dig deeper and extract and understand. Ask questions about vulnerabilities and so on. Of course, again, you need to take permission from big frontier companies or use more permissive models. God forbids you do something you enjoy, you know. Anyway, all right. All right, so this has been one of the longest videos, and I really enjoyed showcasing. I'm not gonna be doing too much editing. Let's consider this like a canonical video and long-term reference showcasing 90% of the abilities. I'm not sorry for the rants. I think I have valid points. And so to recap, I showed almost everything in this tooling. This time I focused on GhidraSQL. I spoke about the architecture and about the dependencies and vibe coding in general and vibe reverse engineering. I touched upon so many topics between basic collaborative headless, not headless UI and agent side by side, you know, cooperative. I definitely showcase headless scenario with multiple binaries at the same time and cross analysis. I showed like from a completely foreigner to hypervisor research. I just showed you very basic thing and never done this before. Opened the hypervisor binary and started digging deep with the assumption that I'm not a reverse engineer and I don't know assembly. I don't even know what's Ghidra. Uh, and I spoke about the trolls and about the current state of frontier companies and how scolding they are and really obstructive, I would say, which is affecting me on a daily basis, unfortunately, and I'm not happy about that. In all cases, thanks for watching and expect maybe a couple more videos around those topics before I move on to new research ideas I have. Thank you and see you next time.